Let's remind ourselves how to solve a different kind of equation. Yesterday in class we looked at quadratic equations, linear equations, and rational equations. So let's look at an equation that has some square roots in it. So the thing to remember about a square root is at some point we're going to need to square both sides of the equation to get rid of this square root. But to make that effective, to make it so that we don't still have square roots lying around after we've squared, first we need to isolate the square root part. So on this equation, we're going to start by subtracting 1 from both sides. And we're doing this because after we subtract 1 from both sides, the square root part is by itself on one side of the equation. So we have square root of x minus 3 equals 3. Once you've isolated the square root part, then square both sides of the equation. So square the left, square the right. And squaring a square root undoes it, so we're just left with the inside. So we get x minus 3 equals, and then on the right-hand side, 9. And then you can finish solving for x however is appropriate for the equation that you have. Since this is a linear equation, we just need to isolate x at this point. So add 3 to both sides, and we get x equals 12. And just as a quick check, if you put this back into the original equation, 12 minus 3 is 9. Square root of that is 3. 3 plus 1 is 4. Yes, that works. All right. So if you have just one square root, isolate that square root and then square both sides. But not every equation involving square roots that we're going to run into is so simple. So here's an example of that. This has 2 square roots and not just 1. So still, at some point, we're going to have to square both sides. But the question is when? It's not really obvious. I mean, you might think, well, there's no time like the present, so let's just square both sides and see what happens. So we'll square both sides here. On the right-hand side, 3 squared is 9. On the left-hand side, well, we're going to have to distribute this whole mess. Remember, when you square a big complicated thing like this, what you're really doing is square root of x plus 1 plus square root of x minus 1. So that's the thing we're squaring. Since we're squaring it, we're multiplying it by itself. So times the square root of x plus 1 plus the square root of x minus 1. And to multiply this all out, well, this is going to take a lot of distributing. So x square root of x plus 1 times square root of x plus 1, that's x plus 1. Square root of x plus 1 times square root of x minus 1, that's plus the square root of x plus 1 times square root of x minus 1. All right. And then square root of x minus 1 times square root of x plus 1. Well, that's another copy of this term that we just got, square root of x plus 1 times square root of x minus 1. So let's just put a 2 in front of that. And then finally, square root of x minus 1 times square root of x minus 1. That's x minus 1. Okay, well, squaring both sides of this equation didn't get rid of all of the square roots, but I don't know, it got these 2 square roots together at least, which maybe seems like progress. Because now we could isolate the square root part and then square both sides again. So let's start by simplifying the left-hand side. So we have 2 copies of x here, so that's 2x. And then plus 1 and minus 1. So this plus 1 and that minus 1 undo each other. Plus 2 times the square root of x plus 1 times the square root of x minus 1. And on the right-hand side, we have 9. Okay, so now let's isolate this square root part. I guess we could start by subtracting 2x from both sides of this equation. We get 2 times the square root of x plus 1 times the square root of x minus 1 equals minus 2x plus 9. All right, and now we can square both sides. Actually, yeah, let's square both sides. Let's let's see, this 2 squared is 4, and then square root of x plus 1 squared is x plus 1. I should be doing this in white for consistency. So 4 times x plus 1. And then the square root of x minus 1 squared is x minus 1. Now on the right-hand side, when we square, we get 4x squared minus, let's see, 2 times 9 is 18 times 2 is 36. 36 plus 81. And let's see, what kind of equation is this? Well, on the right-hand side, that's quadratic. The left-hand side, once we multiply this out, this is going to be quadratic as well. So this equation is actually a quadratic equation. And we know how to solve quadratic equations. Multiply everything out, combine like terms, and then factor if you can, or use the quadratic formula. So let's multiply this out. On the left-hand side, we get 4 times x squared. Let's see, we get, there's an x squared, a plus x, a minus x, and a minus 1. So x squared minus 1 equals 4x squared minus 36. Oh, this should be 36x. So 36x plus 81. Now we can multiply out the left-hand side even more. 4x squared minus 4 equals the same. Let me actually write it out. 4x squared minus 36x plus 81. Now we can move everything to the left, so subtract 4x squared and add 4 on both sides. We get 0 equals, and then we get really lucky because these x squareds cancel, so there aren't any x squareds left over. So 0 equals minus 36x plus, let's see, 81 plus 4, that's 85. All right, now we can finish solving this. It looked like a quadratic equation, but apparently it's actually linear. So now we can subtract 85 from both sides. Negative 85 equals negative 36x. And then divide both sides by negative 36. Oops, 36. And we get that x equals, the negatives cancel, 85 over 36. And we're done. Turns out that equation only has one solution, 85 over 36. So when you're solving an equation with a square root in it, of course the key is at some point you're going to have to square. Exactly when you square kind of depends on the equation that you're dealing with. But once you've succeeded in getting rid of the square root, then continue solving the equation, just depending on what the equation looks like.